Hi everyone, welcome to episode 2 of my Heist Heist devlogs. In this episode I've made some more weapon visual effects and a new object pooling system for all my effects and projectiles. I've also improved the starting submachine gun model, made a holographic gun sight model using a powerful new Blender add-on, improved the player interactions and damage systems using some new C# interfaces, and I've also put in a temporary character customization system. So let's get started. When I first started Heist Heist, the priority was just to get something up and running, so I just used the simplest methods to get the weapons working. This meant just creating or instantiating a new bullet instance every time a gun was fired, and then destroying the bullets whenever they hit something. This method is okay for a proof of concept, but in practice it is a very inefficient way of creating objects that will be frequently needed. That is because every time a bullet or explosion is instantiated, it has to have some memory allocated for it. And then when it is deleted, the memory needs to be cleaned up by the garbage collection system so that it can be reused for anything else that may need it. This process of allocating and freeing memory takes time, and can cause the game to stutter and lose frames. So to keep the game running fast and smooth, we need to implement a better solution. The standard approach to fix this problem is to use a technique called object pooling. Object pooling is a rather simple solution in theory. In this example, I'll talk about how object pooling is used for bullets, but I'm also using it for a whole variety of other visual effects and projectiles. When the level is started, we instantiate a number of bullets that are deactivated and put in our object pool. Instead of creating an entirely new bullet every time one is fired, we simply look for any bullet instances that are in the pool and are free for us to use. We then move them to the correct position and activate the bullet. Once our bullet hits something, instead of destroying the bullet, we simply deactivate it and return it to the object pool. If we cannot find any free bullets in our object pool, we duplicate an existing bullet and the new bullet gets added to the pool. For Heist Heist, I decided to make 2 object pooling systems, one for visual effects such as explosions, fire and blood splats, and one object pool for our projectiles such as bullets and grenades. In my excitement to work on the more fun bits, I rather negligently wrote the effects object pool fully before realising I would need a nearly identical class for the projectile object pool. It would have been much smarter to have made a base object pool class that I could inherit from to make my effects and projectile object pool classes. This would have meant less copy and pasting code and less potential points of failure. But we live and learn. In order to store a list of all my effects and projectiles, I created some new scriptable objects. Scriptable objects are Unity's customizable data containers. This means I can easily edit them in the editor, and I can also create different lists that can be swapped out. So for example, if the game were to run on a high-end PC or PlayStation 5, you would want the visual effects to be more detailed and flashy, and if the game were to be run on a lower spec PC, or a less powerful console like the Nintendo Switch. So by using scriptable objects, I can create different versions of the effects list for ultra, high, medium, and low graphics settings. Both the effects and projectile scriptable objects have 2 lists. One is the default objects. These will be instantiated when the game is first started. This list contains the effects and projectiles that are likely to be needed regularly, so this is our basic bullets, shells, explosions, and dust debris. The other list is for the effects and projectiles which won't be needed quite as often. These will only be instantiated when they are needed in the scene, so the items in this list will be things such as special grenades, or big explosions, or anything else which may not be seen in every game. Now that I've set up the object pools, I needed some bullets to test them with. Jumping over to Blender, I modelled some very low detail bullets. Because the bullets are moving so fast, they don't really need any detail. I also make some spent bullet shells that will be ejected out the side of the gun when the bullet is fired. These are still small, but they will be closer to the camera, so I put a little more detail into these by making a high poly version and baking the details in Substance Painter. Still in Blender, I quickly put together some simple meshes for muzzle flashes and bullet trails. Again, these don't need much detail. I'm relying on the glow from the bloom post effects to do most of the heavy lifting here. I tried applying a dithering effect here to add some transparency, and if anyone from Unity sees this video, can you please let me know why shaders with alpha clipping enabled give drastically different results in the scene view compared to the game view. Getting back on track, now that we have some bullet models, we can test them with our new object pooling systems. First we create a prefab, add it to our list, tell our game how many to spawn when the game starts, and then we can create a bullet, empty shell or muzzle flash with just one line of code. Now to make something a little more fun, we will also make use of the splat visual effect we made in the last episode. Again, I jump over to Blender and start modelling a simple watermelon. And then using the excellent Cracker Blender add-on, I start slicing it into chunks. We can then bring these over to Substance Painter, and using a mixture of pre-made materials and a bit of painting, we can make these chunks look like parts of a juicy exploding watermelon. Back in Blender, I chopped a torso off a model from an old project and stuck it on a large hinge. I then run it through Substance Painter to get this worn-down target practice dummy. After grabbing some sound effects from Zapsplat, our target practice dummies were ready for action. I haven't spoken about the space these target practice dummies live in yet. Much like Helldivers 2, and one of the best games ever, Duck Game, I want the players to be in control of their avatars right from when the game starts. So I've created a hideout space where the squad will be able to relax in between heists, try out new guns, customize their avatars, and plan out their next big heist. At the moment it's just blocked out. The idea is to have a few separate rooms, each with a different function. One of the hideout rooms will be for customizing your character. As the player model is just an early prototype, I haven't made any finalised customization options, just a couple badly modelled haircuts and a few different skin tones. One system that had to be implemented in order to set up the character customization menu was a way for the player to interact with items in the world. I'm calling these items interactables, and they cover things such as buttons and doors in the level, or items that can be picked up off the floor, like dropped guns or grenades. One option to make things interactable would be to have every item's class inherit from a base abstract interactable class. This is a perfectly fine approach for simpler games. But when games get bigger in scope and you have lots of items in your game, inheritance doesn't always work as you'd like. You might end up wanting to inherit a little from one object and some methods from another, and you end up getting stuck. So instead of inheritance, I'm going to use interfaces for my interactable objects. Interfaces in C# allow you to define a contract that classes must adhere to. So in my case, any class that implements the interactable interface must have a method called interact that accepts a character data parameter. This is so the interactable script can send events back to the character that it's interacting with. With this interface code now set up, writing a script for a button that launches a character customization UI is very simple. We simply wait for the character to walk into a trigger collider and check if the collider implements the iInteractable interface. If it does, we activate a little interaction prompt so the user knows they are within interaction range. And once the player presses the interact button on their game controller, we deactivate the player's movement controls, hide the in-game UI, and spawn our new character customization UI. I'm also using interfaces for damageable objects. This includes everything from other players, enemy AI, safes, and even walls. Again, once the interface is set up, it's very easy to use. When a bullet collides with a collider, we check to see if it has a script that implements our iDamageable interface. And if it does, we can then damage that item with our bullet by invoking the takeDamage method. Since releasing the last devlog, a new Blender add-on has just come to the market with lots of potential for hard surface modelling. That add-on is called Conjure SDF. Conjure SDF uses these neat things called sign distance fields for creating really clean Boolean operations. and this allows you to easily create hard surface models that would be very difficult to make with more traditional modelling methods. You can see some footage here of me modelling a hollow site with Conjure, and I was very impressed with it. Conjure is still very much in alpha, but I think I'll be using it for all of my gun and vehicle models going forward. I also created a model of a submachine gun earlier in the week, but unfortunately the time-lapse footage wasn't really usable, but you can see me finishing up the gun here, and combining it with the new hollow site in Unity. And that's as far as I've gotten in this episode. I'm trying to maintain a schedule of one episode every 3 weeks at the moment, so please join me for the next one. Or better yet, click subscribe so you'll be notified when it drops. It would also mean a huge amount to me if you could drop a like or a comment. Every single interaction helps boost the video on YouTube. And personally, I would love to know if you like me covering the programming topics in such detail, or if you're more interested in the gameplay and the visual side of things. Anyway, thanks a lot. Bye for now.